Hey, welcome back to your favorite trigonometry class. We're going to look at trig functions with a unit circle approach today. We're going to define the trig functions using the unit circle. So here's our objectives for this section, quite a few here. So the unit circle is just a circle with radius of 1. Okay, so our radius is 1. Which means since our circumference of that is 2 pi r, that means if r is 1, right, then the circumference is 2 pi for this unit circle, approximately 6.28. So what we're going to do is we're going to define the 6 trig functions using a projection. So what we're going to do is we're going to take a real number line with the origin right there at 1, 0. So here's the point 1, 0 on the unit circle, which is the origin or of the real number line, so the number 0, right? And then all our positive numbers go up here on the number line. Okay, so this is the real number line I'm putting on the circle, and what I'm going to do is I'm going to wrap it around. Okay, so it wraps around, if you can imagine it, wrapping around the unit circle. And what we're going to do, okay, so imagine bending that around, wrapping it around in both directions. We're going to take a t number, I'm going to call it, a number on the real number line, t, and as it wraps around, it projects onto a point, xy, on the unit circle. Okay, I'm just trying to give you a little background for these definitions. Okay, so t on the real number line projects to a point xy that's on that unit circle. Okay, and then we're going to define all 6 of the trig functions that way. So the sine of t is the y value, the cosine of t is the x value. The tangent of t, which the tangent is defined as a quotient identity as the sine over the cosine. So that's the y value, since the sine is the y value, cosine is the x value. The reciprocal of the sine is the cosecant. So the cosecant of t is 1 over the sine, in other words, 1 over y. The reciprocal of the cosine is the secant of t. So that's 1 over cosine, 1 over cosine, which is 1 over x. And finally, the cotangent of t is the reciprocal of the tangent. So it's cosine, my gosh, what's wrong with this thing? Cosine over sine, in other words, x over y. Okay, and that's what these are saying. Sine's the y, cosine's the x on the unit circle, tangent sine over cosine, y over x. Cosecant's the reciprocal of the sine, so 1 over sine, 1 over y. Secant's reciprocal of cosine, 1 over x. Cotangent is the reciprocal of the tangent, in other words, cosine over sine, x over y. Okay, let's do an example. So we've wrapped, if you will, the real number line around. So t, this is a t distance around. So t distance, whatever that is projected onto this point, -1/2 root 3 over 2. And then it's real easy from here. We just find the values of the sine of t. So we say, oh, well, the sine of t is just the y value. Right? I'm looking at that point that it projected onto. There's the y value, root 3 over 2. The cosine is just the x value, so -1/2. There's my x value. The tangent is sine over cosine. So then I just got to clean that up. So multiply by the reciprocal, and you get -root 3 over 2. There's your tangent. The reciprocal of the sine is the cosecant. So it's 1 over root 3 over 2. In other words, 2 over root 3, and then make sure you rationalize that. You multiply it by root 3, top and bottom, so you have 2 root 3 over 3. The reciprocal of the cosine is the secant. So the secant of t, instead of -1/2, it's 1 over -1/2. In other words, -2 over 1, -2. The reciprocal of the tangent is the cotangent. So instead of negative root 3 over 2, instead of y over x, it's x cosine over sine. And then again, we gotta rationalize this as well after we simplify. So I got negative 1 over root 3, negative root 3 over 3 is our cotangent of t. Okay? So sine is the y, cosine is the x, tangent is y over x, and then these are reciprocals. Cosecant's the reciprocal of the sine, secant's the reciprocal of the cosine, cotangent's the reciprocal of the tangent. Okay. Now, so we've done it for any real number t, and since, let me give you a little background again on this. I'm trying to kind of give you some background so this makes sense. Since we're working with the unit circle, and we know S equals R times theta, right? We know that the arc length S is R times theta, right? Well, for the unit circle, R is 1, right? We have a radius of 1, so we have 1 times theta. Oops, S equals 1 times theta. In other words, our arc length is the exact same as our theta. So like if you're looking the unit circle, let's say I've gone, pi sixth amount. So, pi 6, 3.14 divided by 6, about 0.5 something, right? Well, since our radius is 1, that means on the unit circle, our theta is also pi 6. So the sine of theta on the unit circle is going to be the same as the sine of t because our radius is 1. Right? This value is the same as that length right there. That angle rotation is the same as that length on the arc length since our radius is 1. So the sine of theta, the sine of the angle is still going to be y. Cosine of the angle is still going to be x. Tangent is going to be sine over cosine y over x, and so on. So now we can work some other problems. So let's look at the 6 trig functions of the quadrant angle, and I'm going to also refer you to, if you look in Canvas under the trig cheat sheet, I have put a trig cheat sheet in there, which looks like this. And I'm going to refer you to that right now. And you notice it's got the angle, like in this case pi 6 is with the 30 degrees. And so you can refer to this. Here's your unit circle that we're going to refer to, okay, as we're doing these problems. So theta equals 0 radians or 0 degrees. So if I'm looking at my unit circle, I look on my unit circle and I say, okay, find my unit circle. If I do not rotate at all, I'm right here at 1, 0. So no rotation projects to this point 1, 0. So the sine of theta, when theta has not rotated, so the sine is 0 radians, is the y value, 0. The cosine of 0 radians is the x value. The tangent is 0, whoops, 0, theta is 0, is y over x. So sine over cosine, y divided by x, so 0. And then the reciprocals of those would be, so the cosecant of 0 would be 1 over sine 0, but we know the y is 0. So this is undefined. Undefined. Cosecant of 0 is undefined. The reciprocal of the cosine, secant of 0. So that's 1 over the cosine of 0. So 1 over 1. Remember the cosine is the x value there. The x value. Right? So we got 1. And then the reciprocal of the tangent, cotangent. So that would be cosine over sine. So we got 1 over 0. So this is undefined as well. Okay. Now let's do a different one. Now this time let's rotate. Erase this. time it looks like we're going to rotate pi halves. So let's rotate pi halves, or 90 degrees. So I'm looking on my unit circle, starting here. I'm going to rotate pi halves amount, so theta is pi halves. So I end up right here. So I say, okay, what point is that on the unit circle? It's 0, 1. 0, 1. Okay, so 0, 1. So my sine of pi halves, the y value, 1. Cosine pi halves, the x value there, 0. Tangent pi halves, sine over cosine. So 1 over 0, so it's undefined here. The reciprocal of sine, cosecant. So 1 over sine, and we know that's 1 over the y value. Reciprocal of cosine, secant. So 1 over cosine. So 1 over 0, so this is undefined. And finally, the reciprocal of tangent, cotangent. So that's cosine over sine, 0 over 1, which is 0. Okay, and that's how you're going to think about those. Alright, let's do 180 degrees. So now I'm like, alright, I got to rotate pi amount. So my theta is pi. So I start here, I rotate around, my terminal side's right here. So that's the point, -1, 0. That's what I'm looking at, -1, 0. Sine of pi, the y value, 0. Cosine pi, x value. Tangent pi, sine over cosine. Cosecant pi, 1 over sine, 1 over 0. Undefined. Secant pi, 1 over cosine, 1 over -1. Cotangent pi, cosine over sine, undefined. Okay, let's do that last one there with 3 pi halves. So now we're going to rotate around 3 pi halves. So I find on my cheat sheet 3 pi halves. Checks onto that point right there, 0, -1. And I can go through each of those. Sine 3 pi halves would then be the y value. Cosine 3 pi halves would then be the x value. Tangent sine over cosine, undefined, and then again go through the reciprocals with those for the rest of those. Okay, here's just a summary of those quadrant angles that we went through there. All right, how about if it's not a quadrant angle? So we've got, I'm sorry, if I've got more than one rotation, but in this case we do have a quadrant angle, sine of 3 pi. So this is more than 2 pi, so I got to go around. I'm thinking to myself, well, this is more than 2 pi. How much more? Well, I got to rotate 2 pi plus what gives us 3 pi? Well, 2 pi plus 1 more pi. So I got to go around a full revolution and another half revolution. So I go around once, there's 2 pi, and then pi more. So I'm right here on my unit circle, the point -1, 0 on my unit circle. And I say, oh, well, what's the sign there? What's the y value? So it's just 0. How about cosine of -3 pi halves? In other words, -270 degrees. What's the cosine of -270 degrees? So I'm starting here. I'm rotating negative direction, 3 pi halves. So I end up right here, 0, 1. What's the cosine there? Cosine is the x value. So it's, oh, so it is 0, the x value. So cosine of negative 3 pi halves is 0. All right, find the exact values of 6 trig functions of pi fourths, which is 45 degrees. So now I say, okay, I'm going to rotate pi fourths. Right, I'm rotating pi fourths. What's my point right here on the unit circle? So I look at my unit circle and I say, okay, I've rotated pi fourths right there. See the root 2 over 2. Let's see if it'll, oh, it's not letting me. Yeah, goes in. So I'm right here, I've got this point, root 2 over 2, comma, root 2 over 2. So now I can go, oh, sine pi fourths, the y value, cosine, in this case the x value is the same thing, tangents sine over cosine, so we got 1, and then cosecant is 1 over sine, so 1 over root 2 over 2, so 2 over root 2, multiply, or rationalize that, that was just root 2. Secant pi fourths, 1 over cosine, so same thing, you'll end up rationalizing that. Cotangent pi fourths, we've got cosine over sine. Okay, there it is for pi fourths. Now let's do another one here. Let's find the exact value of each expression. So now they're saying, okay, cosine 45 degrees. So I look on my unit circle and I find, again, the 45 degrees, pi fourths is 45 degrees. I'm going to find that spot on my unit circle. And I say, okay, that is the x value is root 2 over 2 because it's the cosine. And now I'm multiplying it by the sine of 270. So now I go on my unit circle and I'm going to rotate 3 pi halves, 270 degrees. So I'm right here, 0, negative 1. On my unit circle, I rotated 270 degrees, 3 pi halves. All right, I rotated, that's where I end up. I got the point 0, negative 1. I know you can't read that very well. 0, negative 1. Sine is which one? Sine is the y value, so that's negative 1. So I'm taking the cosine times the sine, cosine of 45, which is root 2 over 2, times the sine of 270, and there's my answer when I multiply. All right, cotangent of pi fourths minus cosine of 3 pi halves. So cotangent is cosine over sine. Okay, so this becomes cosine over sine. It's the reciprocal of the tangent, right? Or, and then we're going to subtract the cosine of 3 pi halves, which we know the cosine of 3 pi halves is that 0 right there, is the x value. So minus 0, I'm going to do that already. So this becomes cosine of pi fourths. Cosine of pi fourths is root 2 over 2. Sine of pi fourths, root 2 over 2. So we got 1 there, minus 0. So 1 minus 0, which is just 1, to simplify that expression. All right, that's the last one here. Cosecant, let me clean this up a little bit. Alright, cosecant pi force. Well, we know the cosecant's 1 over sine pi force, and then we're going to take that value, square it, and then we're going to subtract secant pi. Okay, so this becomes, so I know the sine of pi force. Here's our pi force. The sine is the y value, so root 2 over 2. And then once we simplify that, we will square it. And then we'll subtract the secant of pi. So I go onto my unit circle, I rotate pi, I find the point right here, -1, 0. The secant is 1 over cosine. And we know the cosine is the x, so -1. So that'll be -1 that goes in right here. So let's clean this all up. So let's clean this up right here. So multiply by reciprocal, right? 2 over root 2, 2 over root 2. Rationalize that. So I have 2 over root 2, which is, this is 2 root 2 over 2, which is just root 2. And remember, this is all squared. So I have root 2 times root 2, which is 2. Minus, I got 1 over, and I've got -1 for the cosine of pi. So 1 over -1 is -1. So 2 plus 1, I got 3 right here. Okay. Alright, let's keep going here. Find the exact values of the 6 trig functions. Oh, pi thirds is 60 degrees. So now let's rotate pi thirds on my unit circle. So go again, you're looking at this unit circle, rotating to the pi thirds amount. See that spot right there on there? Pi thirds. Oops. Pi thirds. Rotation. What's the point right there? When you look at that point, if you look back again, do you see it? Pi thirds, you got that 1/2 root 3 over 2. Okay, so then you can do the same thing. Sine pi thirds, y value. Cosine pi thirds, x value. Tangent pi thirds, sine over cosine. Cosecant pi thirds, reciprocal of the sine, so 2 over root 3 or 2 root 3 over 3. Secant pi thirds, instead of 1/2, it's 1 over 1/2, so 2 over 1 or 2. Cotangent pi, whoops, that's pi thirds. Pi thirds is cosine over sine. So I've got 1 over root 3 or root 3 over 3 on that. Okay. So similarly, if you were to do it for like pi 6, we'd go through that same process. So we'd find pi 6 on our unit circle, and I find that point, and I say, oh, what's my point right there? Root 3 over 2, comma 1/2. Again, I'm looking on my unit circle. At pi 6, I got root 3 over 2, comma 1/2 there. And I go through all those 6 again on that. Okay? Now, if you notice on your unit circle, like at pi force in quadrant 1, if you look at 3 pi force, in other words, 135 degrees, you've got the same y value because it's at the same height, but the x value is just going this way. It's it's x amount this way instead of positive root 2 over 2 x value. It's negative root 2 over 2 for the x value. So it's negative x up y. And then down here it's negative x, negative y. Down here it's the same x but negative y, right? For 5 pi force and 7 pi force respectively. So study that. Really, you're going to start seeing a lot of patterns as you use this unit circle quite a bit. Right now it's a reference, and at some point you should be able to create that. We'll talk about that in the course. Okay. Sine of 5 pi fourths. I'm actually, you know what, I'm going to stop right here. I'm already over time and make another video at this point. Thank you for listening. See you guys next time.